this tutorial, you will learn how to calculate an independent samples t-test by hand. We will calculate this test assuming that we have unequal variances. An independent samples t-test is conducted when we have two independent groups and we want to know if the populations that these groups represent differ. Our question asks, a researcher at a university wants to determine if female college students sleep significantly longer than male college students. The equation for our t-test will simply be t equals x bar 1 minus x bar 2. That represents the difference between our two sample means, minus mu1 minus mu2. This represents the difference between the populations. Our denominator will be the standard error, and we will use the equation assuming that our variances are not equal. So this is the standard deviation squared of group 1 divided by the size of group 1 plus the standard deviation of group 2 squared divided by the size of group 2. There is a different calculation to do if you can conclude that the variance of the populations are equal. We will not cover that in this video. The first step of any t-test is to write our null and alternate hypothesis. In this test, our null hypothesis and alternate hypothesis must include the two groups that we're comparing. So we are comparing the difference between the population of female students and the population of male students. The question asks us if female college students sleep significantly longer than male college students, and see if this difference is greater than 0. The reason we are checking to see if this difference is greater than 0 is because we expect the female college students to sleep more based on the question in the test. If the female college students are sleeping more than the male college students, we expect this difference to be positive and greater than 0. The null hypothesis is always that this difference is equal to 0, as in there is no difference between our two populations. Now we can begin our test. Let's fill in our t-statistics. T is equal to the difference between our two sample means. So female sample had a mean of 7.95 hours, and the male sample had a mean of 7. We subtract from this the value that we're comparing in the null hypothesis, or our null hypothesized mean. And we're comparing in our null hypothesis to a value of 0, so we just subtract 0. Then we divide by our standard error. Our standard error is the square root of the standard deviation of the female college students, which is 1.88, squared over how many there were, which was 51, plus the standard deviation of the male college students, which was 3.06, squared divided by how many there were, which was 41. If we work all of this out, we come to a value for our t-statistic of 1.73. Now we must compare this value to a cutoff so that we can determine if we can reject or fail to reject the null hypothesis. This is the t-chart that I will be using for this demonstration. There are many versions of this t-chart, but they all function similarly. On this chart, we must first decide if we were conducting a one- or two-tailed test. Since our alternate hypothesis includes a greater than symbol, that tells us that we have a one-tailed test. If our symbol had been not equals, that would tell us we were looking at a two-tailed test. Because we were expecting our t-statistic to be positive, because we have a greater than hypothesis, we are conducting a right-tailed test. For our degrees of freedom, we will use a conservative estimate because we are not using the assumption that our variances are equal. Since we are assuming our variances are unequal, we will use the conservative degrees of freedom, which is the smaller of n1 minus 1 and n2 minus 1. The female sample was 51 for degrees of freedom of 50. The male sample was 41 for degrees of freedom of 40. Since 40 is the smaller value, we will use that as our degrees of freedom in this test. So for a one-tailed test at a p-value of 0.05 and a degrees of freedom of 40, we have a t-critical value of 1.684. Now we need to compare this value to the t-statistic we calculated. Drawing out the null distribution, we see our critical value is at 1.684. Our t-statistic was at 1.73. Remember, 0 is in the center of our distribution. So our t-statistic of 1.73 is more extreme than our t-critical. Therefore, we can conclude that we can reject the null hypothesis, and we can state that female college students do sleep significantly longer than male college students.